Welcome to NJP Online Mathematics. Let's solve this problem involving factorial notation once more. So for us to do this, we have to solve this problem given the solution. And the problem is p factorial to the power p factorial plus p factorial all to the power of half p factorial equals 2. We should determine the value of p as a positive integer. So we have the problem p factorial to the power p factorial plus p factorial to the power of half p factorial equals 2. So from here, we need to take note from the general notation that p factorial for every positive integer must be greater than 0. That is to say that all the values for p factorial must not be less than 1. So if we have to continue here, it means that p factorial must be equal to 0 plus k, that a certain number must be added to 0 to have p factorial. Since p factorial is greater than 0, we don't know the value of k, so p factorial equals k. So we have gotten equation 1. So since we have gotten the initial equation 1, that p factorial equals 0, we need to substitute the value of k in the equation for p factorial. So if we continue, then we are saying that k to power k plus k to the power of half k equals 2. So from here, we can express this in form of indices that k to the power k plus k to the power k, applying the law of indices, we are having half equals 2. So we've seen that we are having k to power k, k to power k. So we can let k to the power k to be equal to a. And we call this the second equation that we have just obtained. So we have to substitute the value, the variable for k to the power k there. And we are having a plus a to power 1 over 2 equals 2. So we can express this to be a plus the root of a equals 2. So we can make the ones without square root to be on one side and the ones with square root on the other side. That is a minus 2 equals minus root a. So from here, we can take the square of both sides. We can square both sides. And if we square both sides, we are having this. So definitely, this becomes a square minus 4a plus 4 equals, this becomes a. Remember, when you square a negative sign, it becomes a positive sign. So we now have to take this to the left hand side, and this we are having a square minus 4a minus a plus 4. Since this was positive, when we take it to the left hand side, it becomes negative, equals 0. So from here we can group it up, and a is common in the first bracket here, and we will left with a minus 4 minus 1 is common here, and we are left with a minus 4, since minus minus will give us positive, equals 0. So from factorization, since these are the same, we are having that a minus 4 multiplying a minus 1 equals 0. So it's either a minus 4 will be equal to 0, or a minus 1 be equal to 0. Therefore, a equals 4 or a equals positive 1. So we have just obtained the value of a in the equation here. So the next step is to recall from the two relationship that we just derived for ourselves to determine the value of p. So we said that k to power k equals a. So from here, it means that k to power k equals 4, which is the value for a, or k to the power k equals 1. And we know that 4 is a perfect square and 1 is also a perfect square. And 1 raised to the power of any number is 1. That means 1 to power 1 equals 1. And for 4, 2 to the power 2 equals 4. This is a perfect square, as well as 1 is a perfect square. So we can write this to be k to power k equals 2 to power 2, or k to power k equals 1 to power 1. We can see clearly that this is k and this is k, this is 2 and this is 2, which then means that we are having this equals this, or this, and then k equals 2, or k equals 1. Therefore, we have obtained two values for k. So we need to continue from our relationship where we solved out. We need to now determine the value of p factorial. Recall that we said p factorial equals k. So since p factorial equals k, p factorial equals k, we need to continue because we said p factorial will be equal to 2, which is the value of k, or p factorial equals 1. But we need to remember from the factorial notation that 0 factorial equals 1, 1 factorial equals 1, 2 factorial equals 2, and 3 factorial equals 6. So our values here, 2 and 1, falls between this and this. So we can now substitute this in place of 2, this in place of 1, or this in place of 1. So if we continue, we are having that p factorial equals 2, and 2 is 2 factorial, or p factorial equals 1, which is 1 factorial, or p factorial equals 1, which is 0 factorial. 0 factorial. We have now obtained three values for p here. So we have to continue by saying that p equals 2, or 1, or 0. So since we have obtained two values, three values for p, we need to check from our relationship if these three values of p, we have to satisfy the equation that we were given, that p factorial to the power p factorial plus p factorial to the power of half p factorial equals 0. So from here, we need to see that for this to be equal to 2, then we'll be having that p factorial must be less than must be less than 2. P factorial must be less than 2, because 2 to the power 2 added to 2 will be 6, which will be greater than 2. Therefore, p factorial must be less than 2. Since p factorial must be less than 2, then it means definitely that p, which equals 2, is not a real solution to the problem. And now we are left with p equals 1 or 0. So we need to check from the equation whether we are truly having that p equals 1 or p equals 0. The relationship was p factorial to the power p factorial plus p factorial all to the power of half p factorial equals 2. So from here that this equals to, we need to substitute for the value of 1. We know 1 factorial will give us 1. So 1 to the power 1 plus 1 to half 1, which is still 1, and 1 to any number is 1. That means we're having 1 plus 1. 1 plus 1 is definitely 2. So let's check for 0 factorial. We know that 0 factorial to the power 0 factorial plus 0 factorial to the power half 0 factorial equals 2. So 0 factorial is 1, so we are having 1 to power 1 plus 1 to power half of 1, which is 0 factorial, and this is definitely 1 plus 1, since 1 to anything is 1, and this equals 2. Therefore the values of x of p to satisfy this equation becomes 0 or 1. Thank you for watching. Kindly like and subscribe.